Hey guys, time to solve some more advanced systems of equations. These are nonlinear systems, so we are going to first try these by substitution. You can always try them by graphing, all right, but you just find the intersections. That's a piece of cake. That you know how to do already. So let's go with substitution. Notice that both of these functions are in y equals. So this means I can actually set them equal to each other. So I'm going to say negative 35x plus 28 is equal to 5x squared minus 35x plus 8. What I'm going to do is I'm going to add both of my terms, or move both of my terms, I should say, to the right side, because quadratics, we like to have them set equal to 0. So we're going to have a 5x squared, and then negative 35 plus 35. Well, that's going to cancel out my linear term. And subtracting 28 from 8 gives me minus 20. All right, so I've got this quadratic without a b term. I can actually factor this quadratic with the GCF. So I can factor out my 5, and I'm left with x squared minus, and that will give me a 4. All right, so I've got this itty-bitty quadratic that I can factor, and that is going to factor to x plus 2 times x minus 2. All right, which is fantastic, because with this, now I know my zeros. My zeros are x equals negative 2 and x equals positive 2. All right, this is really good news. Now I have both of my values for x that will solve the system of equations. So all I need to do now is I need to take these individual x values and I need to substitute them back in. All right, so when I substitute it into the first one, I get y equals negative 35, I'm evaluating, times negative 2 plus 28. So negative 35 times negative 2 gives me 70, and 70 plus 28 gives me 98. All right, so now I have found the corresponding y value for my first evaluation. Next, I'm going to substitute my second x value into the linear function, and you can actually substitute it into either one. All right, I just think the linear one is a lot easier. So substituting a 2 into this x gives me negative 35 times 2, which is negative 70, and negative 70 plus 28 gives me negative 42. All right, so that is negative 42 for my second y value. All right, just double check that. Very good. All right, and let's see what we've got. We enter these. Again, you could look at the graph and you would see that, in fact, as a matter of fact, they intersect at these 2 points. So my first coordinate was negative 2, 98, while my second coordinate is positive 2 and negative 42. All right, we check this, and it looks like this is fantastic. So that's how you solve a system of equations by substitution. All right, now here's a second example where I made some magic happen. Yeah, come here so you can see. We've got like a minute left to record. Okay, so we've got an equation in x equals and an equation that's not even close to being an x equals or y equals. So we're going to use substitution a little differently in this case. We're going to take the first equation, which is an x equals, and we're going to substitute it into the second equation. All right, so we're going to substitute negative y plus 12 into equation number 1. I invite you to pause and maybe try out the steps. So that's what we first did right here. And when I substitute negative y plus 12 into this x, I'm going to have to go through the steps, square it. I use my box right here to square it. I end up with y squared minus 24y plus 144 plus y squared equals 104. All right. Combine my like terms, I end up with this 2y squared minus 24y plus 40. Next, I'm going to factor with a GCF right here. I factor with a GCF, factor out my 2. And I'm left with a quadratic, y squared minus 12y plus 20. All right. And then I factor that quadratic into y minus 10, y minus 2. This reveals the zeros. 30 seconds left. And we've got y equals 10 and y equals 2. Just like the previous problem, I'm going to take these individual y values and I'm going to substitute them back in to my linear function. I get x equals 2 and x equals 10. And probably won't have enough time to submit these answers for you to see, but they are correct. All right. And that is, make sure that you substitute them in the correct order. Right. For example, the first one would be 2, 10. The second one would be 10, 2.